Hi there, my name is Gregory Carlson and welcome to 2.3 part 3. Here I've got a function right here, f of x is equal to negative 6x plus 6. And so now it's time to talk about this f of x, because this is the cause of some confusion in algebra. F of x is the name of the function. It's another way of writing y. So we could also write this equation as y equals negative 6x plus 6. Now you know that if I plug in a number for x and do a little bit of math, I'm going to get a number for y. So if I put in an input for x, I'll get an output for y. That's great. It's the same thing here. If I plug in an input for x, I'm going to get an output for f of x. In other words, this is not f times x. This is f of x. There's no such thing as solving for the f. Okay, you think of this as just being glued together. The reason f is nice is because if I write f of 3, I know what the input is. I know that the input is 3. And so we want to find the output. And so what we're going to do is when they're saying find f of 3, that means in your equation, every time you see an x, replace it with a 3. And as you can imagine, we're going to get a number. We're going to get an output. So let's do that. Let's plug in 3 into our function. And so you just replace x with a 3, and then just do order of operations to figure out what the number will be. So negative 6 times 3 is negative 18. And negative 18 plus 6 is negative 12. So in other words, f of 3 is equal to negative 12. And that's the end. This function is called f. 3 is the input, and f is mapping 3 to negative 12. 3 is in the domain because it's an input. Negative 12 is in the range because it's an output. We do not try to solve for f. F of 3 is a number, and that number is negative 12. So hopefully that makes sense. Let's find f of 2/3. This is a new problem, but we're using the same function. So this time we're going to replace x with 2/3. So f of 2/3 would equal negative 6 times 2 divided by 3 plus 6. Just like that. So let's simplify. Negative 6 cancels with 3 and becomes negative 2. So I have negative 2 times 2, which is negative 4, plus 6. And so f of 2/3 is equal to negative 4 plus 6, which is 2. So you can see that this function maps 3 to negative 12, and it maps 2/3 to 2. This is good. If 3 was getting mapped to two different numbers, it wouldn't be a function. Let's find f of 2/7. Again, we're just going to use this function. F of 2/7 is going to equal negative 6 times 2/7 plus 6. There we go. Let's simplify a bit. 6 and 7 don't cancel, so this will be negative 12/7, because 6 times 2 is 12, plus 6. All right, we have some fractions, so let's combine them. This is the same as 6/1, and so I need to find a common denominator, which is going to be 7. So multiply the top and the bottom by 7. So this is negative 12/7 plus 42/7. And now we can add the fractions. Negative 12 plus 42 is 30. So in other words, f of 2/7, the input of 2/7 gets mapped to the output of 30/7. So these three numbers are part of the domain. These three numbers are part of the range. And be aware that because this is a line, this is a graph of a line, the domain is all real numbers and the range is all real numbers because it's a line that's not vertical or horizontal. Now this next one's a little strange, f of x plus 8. Remember, this is what we are plugging into the function. So you can see that this time we're not plugging in a number, we're actually plugging in the quantity x plus 8. Luckily, it's still pretty simple because we just replace whatever the x is with all of x plus 8. So in other words, f of x plus 8 is going to be a new function. It's going to be negative 6 times, instead of writing x, we write in what we're plugging in, which is x plus 8. And then don't forget the plus 6 at the end. So this is the same as this, except I replaced x with x plus 8. And let's simplify that a little bit. Do the distributive property. That'll be negative 6x minus 48 plus 6. So the final answer is f of x plus 8. Combine like terms. Negative 6x. Negative 48 plus 6 is negative 42. So we have a new function. F of x plus 8 is a new function. If we wanted to, we could call this function g of x, or give it some other name. See if you can do this next one on your own. See if you can find out what this function would be. Go ahead and pause the video and see if you can get it. Hopefully you gave it a shot. Let's see if you got it. Here's my starting function. F of x is negative 6x plus 6. We're going to replace x with x minus 3. So f of x minus 3 is equal to negative 6 times x minus 3 plus 6. So here we go. Do the distributive property. Negative 6x plus 18 plus 6. And then we're just going to combine like terms. So the final answer is f of x minus 3 is equal to negative 6x plus 24. Not too difficult at first, I hope. Remember, f is just the name of the function. We never try to solve for f. F of 3 is the output. It's the same thing as y. The 3 just tells us what the input was so that we got that output. All right, last question on this section. Here we've got a function because it passes the vertical line test. And they want to know, state which intervals the function is increasing, decreasing, or is constant. Here's something that's really important. Do you see this word? Well, it doesn't say it in here, but when we're talking about when something happens, when we're talking about when is the function increasing, or when is the function decreasing, when is x. It's the domain, okay? So when we're talking about when something happens in a function, we're talking about the x values that it happens, the domain. The y values, on the other hand, the range, that's the what. That's the what is happening. And that's going to be more useful when we're talking about applications. Like, for example, let's say that this is your heart rate. We see that our heart rate went down because we were relaxing. Then we walked up some stairs, so it came up. Then we sat in a chair, so it stayed constant. So here was when the x is when our heartbeat is changing, and the y is what our heartbeat is doing, as an example. So let's see what intervals it's decreasing. So it is decreasing all along here, and so it's decreasing from negative infinity all the way to negative 3. So our domain, when we're looking at the x, is going to be negative infinity to negative 3. And I would put parentheses around both of those, because you'll learn in calculus that this point, kind of some weird stuff happens here because it's a sharp corner. This point is not continuous, which we'll talk about later. And so I wouldn't include this as part of the decrease. Hopefully your homework won't include it either. Where are we increasing? Oh, I'm sorry, I made a mistake. The x value here is negative 5. See how easy it is to make a mistake? We need to always be looking at the x values when we're doing this. So that should be negative infinity to negative 5. Sorry about that. Let's see when the function is increasing. So here's where it's decreasing. It's increasing looking at the x values from negative 5 to 2. And again, I would not include the endpoints of that interval because these are kind of sharp corners. It's hard to say what the graph is doing right there. So we're increasing from negative 5 to the x value of positive 2. And where are we staying constant? We are staying constant from here on. So from 2 approaching infinity. And that's where the interval, when we're talking about x values, is increasing, decreasing, and staying constant. Hopefully all of that makes sense. If you have any questions, please leave them in the comments below, and I'll try to get to them. If you like this video, if it helped you, please like and subscribe, and I will see you in the next section, section 2.4. See you then.